Okay, uh, so we'll this is the agenda. We'll be going through uh, Linux socket design, basic socket design. What are the system calls involved for sockets inside the kernel? And the socket design has multiple layers. We'll look through that, and the data structures which are used in sockets, and how what happens when you create a socket. What happens internally in the kernel? Similarly, when the user program sends a data or receives a data, there are a couple of sequence involved in the kernel, like which layer is called in what sequence. So we'll look at all those things today. Okay, so the entire socket design in kernel is based on BSD socket model. Have you heard of this thing, BSD socket? Okay, so let me give you a small history behind it. So BSD stands for Berkeley Software Division or Distribution. Yeah. So originally the entire Unix, most of the Unix you see in the market today, like HP Unix, Solaris, and many other variants like IRIX, all those Unix is derived from BSD. So I can say BSD is the mother of almost all the modern Unix, and of course Linux has derived from Unix. So Linux also has roots from BSD. So BSD originally came up with the socket model or the idea of socket. So they implemented the own system calls and design. So currently Linux as well as Unix, the implementation is based on that borrowed model. Yeah. So essentially, socket layer, actually speaking, like it just acts as an interface between user process and the protocol layer by using this abstraction. In a simple way, what is a socket? Uh, so other thing is, as far as user is concerned, only a socket file descriptor is returned. But internally, what happens is the socket layer in the kernel, it also interfaces with the file system. So what I when I mean it interfaces with the file system. So what happens when you get a socket descriptor? You can use any standard Linux system calls like read, write, close. So all those things, what happens? It goes through the Linux file system layer. Inside the file system, there is a distinction. There's the file system layer code distinguishes between whether it's a normal file or a socket file. So if it is a socket file, then the control goes to the socket layer. If it is a normal file, then the control goes to the file system layer, the file system pertaining to that particular file. So that's where like that's where the flow actually forks into two different portions. So the socket layer is responsible for that particular flow actually. When you create a socket, the socket layer will set some information in the file system to tell the file system, okay, this is a socket file, anything related to the operations, finally the socket layer functions has to be called. Oh, so we looked at this before, like the socket abstraction supports different kinds of protocol families or domains. We saw that AF underscore INET, INET 6, IPv6. So, and other thing is, apart from this, the socket layer implementation in kernel also supports uh, uh, connection oriented and connectionless using the stream and dgram, also socket raw for implementing direct protocol layer packets. Actually, you can just skip TCP and UDP, you can directly send it to IP. Okay, so yeah, correct. So Linux socket system directly lands in the socket layer. Then once the socket layer makes some connections with the lower layer, it goes to the protocol layer. So essentially the Linux kernel implementation of socket contains two layers. One is the kernel part of the socket and another is the protocol part of the socket. Yeah, correct. So the kernel part will be very close to the user socket part. It will maintain the socket state. It will maintain information about whether it is a TCP or UDP and things like that. So finally, that goes to another layer which is protocol dependent. So for example, you have TCP, IP, and UDP. So for every protocol there will be a socket related code that will be using the protocol stack. So this is the overview inside the kernel. So far we have seen only the user space here. Yeah, socket layer. So the kernel part is where, as I said, like VFS stands for virtual file system. So this is the file system abstraction kernel provides. From here, the control goes to the socket layer. Once the or if the file system file correct. So whether it is a normal file or a socket file. So based on that, the control will go to kernel socket. Then the control will go to the protocol dependent socket layer. Okay, so this is another way. Only thing is here we can see list of sockets actually. The moment if it is a stock stream, the control will automatically go to, one second. Yeah, if it is a sock stream, the control will automatically go to TCP. If it is dgram, it will go to the UDP protocol layer. And if it is raw socket, it will go to the IP protocol layer directly. And so there is one more type of socket. I think you also talked about it in our first or second session. There is a separate domain, one other domain called packet. So here you can directly form the entire TCP IP and Ethernet and send it to the network device. So this correct, exactly. So in fact, like if you know the TCP dump tool, right? So it does the same thing. So only thing is the TCP dump just reads. It doesn't write. It just reads the packet from the network interface and prints out all the information. Yeah. And these are all the special sockets which will interface to the. Sorry. Yeah, go ahead. Go ahead. Sorry. Yeah. Protocol family, I don't think the packet, there is no protocol family. Yeah, you can just give 00. Only thing is this requires root permission like raw socket. Okay, and another type of socket is like a netlink socket. This is used to connect to kernel code. For example, like you might have heard about IP tables. So IP table, when you program the rules in the command line, it actually gets stored in the kernel part of it. So how the entire communication between the user process and the kernel code happens is through the PF netlink sockets. Yeah, so if you see there is a macro called netlink underscore firewall. So this particular netlink socket is used by the this thing kernel firewall code and the user space IP table. And similarly, correct, to get and set the firewall rules. And one more example is if you see the netlink route, it is used to manipulate the routing table. So originally what happened is like each of these layers they had ioctl, but going forward they saw netlink socket as a much more superior interface. So most of this special kernel code moved to Netlink user interface. Arc daemon, yeah, but I've not used it much actually, so I'm not sure like how exactly it will be used. Okay, so going forward, like these are the system calls related to user space socket thing. So as you can, I mean, it's sys socket is the one which is called when the user gives a socket system call. And similarly, you can see bind, listen, connect, all the similar name. So it's a very standard convention in Linux kernel. Like all the system calls will start with sys underscore. And the implementation, you can, I mean, it's very detailed things are there. And if you go to Linux net socket.c in the kernel source code tree. Okay, so the main thing is this data structures. This is where the entire things are stored. So the struct socket, this is a kernel data structure. This is the primary socket or the what do you call the socket equivalent of the user space socket. So this exactly, yeah, kernel equivalent of that, yeah, correct. So this is primarily used to keep track of file system and socket binding. So I was saying about the file system will have some information to distinguish. So it will hold the, so the thing is like file system will have a pointer to socket and socket will have a file pointer to file system. So it will be like a cyclic reference. Correct, correct. So now what I am saying is like say the moment you do something in the socket file descriptor and user space. Say for example you are sending a data using write system call. So that write system call goes to the file system. There the check will be done whether the particular file is a normal file or a socket file. So if it is a socket file, then what happens is like there will be some socket related functions which will be called. So in that function, one of the parameter will be struct socket. Since the kernel socket information is stored in this, so all this socket related calls which will be used by file system will have this as a main argument. Okay, yeah, key data structure. So it's actually very big inside the kernel. So what what we can do is I'll show you a very simple two, three main data structures related to this. Okay, so second thing is second structure which is connected to the socket structure is proto. So this contains all the function pointers or the implementation of a socket in the socket layer. Like for example, bind. Also, all the system calls what we saw in the previous slide. Like for example, sys underscore socket. All will call the socket implementation of this. Like you have bind, send, receive. Yeah. So this is where this will be the place where the system call will land actually. No, not information. It will contain the function pointers. Yeah. So this function pointers will essentially point to a socket information, socket specific implementation. So correct, correct, correct. Yeah. So this is only the kernel part of the socket. So now this so far we have not touched anything related to protocol here. This is protocol independent layer up to this. So now the third and fourth data structures are related to protocol. So what happens is once the upper part is complete for a socket, the lower part comes into picture. So the struct sock actually keeps track of socket state as well as pointed to protocol layer functions. So this is where exactly the socket data is sent to the correct protocol. So if it is a TCP socket, then the struct sock will contain information regarding the TCP layer, and it contains one more data structure called proto ops. This is where exactly all the implementation of a protocol will be contained. Like for example, if you are sending it, then it will call the particular TCP related send. For example, you are using a TCP socket and trying to send some data, then using the function pointers in the proto ops, the data will be sent to the protocol layer. So correct, correct, correct. So the proto-ops is the another main structure. It will contain the function pointers which will have the functions implemented for a particular protocol. So for example, there will be function like TCP v4 underscore send. So that TCP v4 send will send the particular data in a TCP protocol specific way actually. Correct. And similarly, if it is UDP, it will have a UDP related thing or IP. And another main data structure is this struct net proto family. So this particular structure is the one which is first used, very first structure which will be used after the socket is this structure. It will contain only a single function pointer, which is to create the binding between the kernel socket as well as the protocol layer socket. So if you see the above two things, right? So far we just talked about what each of the structure, each of the socket will do. But the thing is, these two sockets has to be connected together. So that will be done by the create. Actually, this structure will contain a function pointer to create. So that create function will be implemented by the particular socket, this kernel socket. Correct, correct. So it will contain a function pointer like create. That create will be called when a socket is created from this layer. So what the moment this layer calls the create function, it will pass the pointer of this layer and it will call the create. This create internally it will create a struct sock and connect this with this. Yeah, so there is a code flow I think in the subsequent slides. So I think that will be very clear about how exactly the create works. Okay, so here I mean I have given the exact details. So for example, you have this user space bind listen. It will come to this protocol independent inet bind inet listen. Assuming you are creating inet family related socket. Correct, correct. So so assuming it is a TCP socket, then it will go to TCP specific protocol functions like TCP accept, connect, send message or receive message, etc. Okay, so if you see the correct, correct. Yeah, SK as a protocol field that will contain the this thing. Protocol field is proto ops actually. This is the one, and sock hyphen ops is actually struct proto. So here, so this is where I mean. So this is where like socket dependent functions will be filled, function pointers, and protocol dependent function pointers here. So if you see this TCP underscore prot, this is a proto structure which will contain all these functions in the structure. Yeah, it is structure of this type, structure proto-ops. Okay, so this is exactly the socket creation part. So the first socket creation combines the VFS and socket layer. So VFS stands for virtual file system. So this first function will connect the file system and the socket layer. That's the very first thing will be done. Yeah. So higher layer socket, or you can also take it as kernel socket. So this is where the entire connection happens, like file system, kernel socket, and the protocol layer. Everything is connected now. So like, if you take inet socket, this particular function inet underscore create, it will do this entire thing. No, it will combine the it will combine the kernel socket and the protocol layer socket. So the file system and socket will be done by the higher level kernel socket code. So if you see this, the last structure we talked about, net proto family. So that create is called here. Finally, using the function pointer. Yeah, so that create will point to, if it is the inet socket, it will point to the inet create here. Yeah, yeah. Entire layered approach, it uses structures and function pointers. Yeah, let underscore families. That's a array actually. So for all the socket family, for example, we talked about AF underscore inet, inet6, IPX. So everything will be stored in this array. The function pointers for those family. So the plan what I'm having is, once we finish the socket layer implementation, you can implement your own protocol using the socket layer in the user space as well as kernel. Yeah, you can write a simple protocol just to send and receive to understand how the entire layer works. Yeah, sure. I'm preparing it. I'll just attach it in the student portal. You can use that instruction to follow the sequence. Okay, so we saw about creating a socket. Now we'll see about sending the data using socket. So the very first thing is, like, once a user space program has sent a data using send or write, the socket layer code will copy it to the kernel. That is the first thing done. Okay, so yeah, so once it is done, the second thing is, like, the file system layer socket code. So that is a separate part of it. It doesn't know about the only that layer knows about the socket. That's where the file system control ends, the socket thing starts. So there another mapping will be there, like to map the particular user space socket to a kernel space socket. Once that mapping is resolved, the struct sock will be retrieved. Yeah, once from the mapping, once struct sock is received, you can call the socket layer functions, socket specific functions, like the previously we saw inet underscore send, inet underscore send message. So that will actually call the struct sock layer. So in turn, the struct sock will help the higher layer to call the protocol specific layer, like TCP v4 send or UDP v4 send. So this is where, for example, this is the upper layer, sock ops underscore send message. This will in turn call the SK pointing to SK. What is it? The previous one? Yeah, SK prot. pointing to TCP underscore send message. Correct, correct. Yeah, so it will go to struct kernel socket layer. From there, you will get the inet underscore send to. Okay, so this function is called to resolve the what do you call that the data from user space to kernel space. No, no, not resolve. It is used to copy the data from user space to kernel space. You are sending some data, right? You'll be sending it to a user's address space, user space address space. Correct, correct, kernel address space. And this function will resolve, the sock from file will resolve the mapping so that it gets a structure sock from the file descriptor. I mean, sorry, I might be wrong. Actually, fget underscore light is not the one. That's a copy. I mean, ignore that. So this is the one which does that move ADDR to kernel. Yeah. So I'm not sure like exactly what does. I mean, I probably I can get it for you. No problem. So once this socket is resolved and file system, the data is copied to kernel space, then using this two layer mapping, the data will be sent to the final protocol layer. So once the data goes to the protocol layer, then where does it go? It has to be, it will go through, okay, so it depends actually. For example, if you are, let's say you are using a sock stream and AF underscore inet. So then it will go to the IP layer. Yeah, and if you are using, say, AF underscore packet, so then it will directly go to the Ethernet driver, or you can say L2 layer. In case if you are using sock underscore raw and AF underscore inet, then it will go to the IP layer directly. So based on the socket type, the protocol layer pointers will be different. Okay, so for receiving the data, the concept is same. Only thing is the function pointer will be different and the sequence of copy will be different. So earlier, what we saw is like we saw the fget light followed by move address to kernel. But in this receive case, mapping is resolved. Once you get a struct sock, you can call the protocol level receive. And once that succeeds, then you will be copying the data to user using this function. Move address to user. Yeah, so this is a very basic socket implementation. This can be used irrespective of protocol. It doesn't matter what protocol you can use at any layer. You can use these things. So how is this? I mean, the thing is like, is it easy for you? Like you find it complex or how is it? Correct. So the thing is like you have to look at the data structures. You have to look at so it will be very clear once you do a K-probe. Now because the theory part is just it is very abstract representation. The moment you go through the code walkthrough, once you start going through the struct sock in the kernel code and struct socket, you'll be able to appreciate the bindings actually, how exactly these two structures are related to each other. The kernel part of the socket, like it involves a lot of code walkthroughs actually. When I say inet underscore create, probably it is very big, but actually you can go through the important places where the binding is done. For example, inet underscore create creates a binding between kernel socket and the protocol layer. So those things, like if you go through, then it will be very easy for you. Yeah. So first, what I'll do is I'll send you the K probe. Just attempt with it. What Unix what Linux you are using? Okay, Ubuntu should not be a problem. Ubuntu 11 or 12.